We're going to take a look at proof of law of sines for section 6.5. Not a very hard proof, at all. Let's consider this triangle right here. It is not the right triangle. Let me make that clear. It is not the right triangle. Let's call this A, B, C. And this is most common proof that you'll see. Most teachers, this is the way they show the proof of law of sines, but there are other ways. So I do have a triangle ABC. It's not the right triangle. If I drop a perpendicular from angle C down such that it'll make 90 degrees, with AB. Okay. And let's see, since I have angle A right here, let me go ahead and call this side A, side opposite. I have angle B in here, and so I'm going to go ahead and call the side opposite small case b. And finally, since angle C is up here, I'm going to call this blue light line segment C. Okay. And for the lack of better, choice, the perpendicular that we dropped, right, let's just call this H, like maybe for height. Okay. Now, what is it that I can say from this picture? One of the things that I can say is that sine of angle B equals the side opposite, which is H, over the hypotenuse, which is A for this small triangle. So so notice that when we drop the perpendicular from angle C, now we made two smaller triangles from the big triangle. Now let's look at the small triangle on the right-hand side, okay, and consider angle B. Sine of angle B equals side opposite H divided by the hypotenuse of that smaller triangle, which is A. Okay. If I multiply both sides of this equation by A, now I can claim that H equals to A times sine of angle B. Okay. And what else I can claim from here, from the drawing? I can claim that sine of angle A, that sine of angle A equals to side opposite of A, which is H, divided by the hypotenuse of the left-hand side triangle, which is B. And if I multiply both sides of this equation by B, I will have H equals to B times sine of angle A. Okay. Now, notice that here I have H equals to this and H equals to this. And we are talking about the same H, the same height. So A sine of angle B must equal B sine of angle A. So I'm going to go ahead and rewrite this as A sine of angle B, okay, equals to B sine of angle A. Okay. And if I go ahead and divide both sides of this equality by AB, So divide this by AB and divide this by AB. Notice that I can cancel the A with this A. I can cancel this B with this B. So what I have is sine of angle B over B equals to sine of angle A over side A. So I can go ahead and draw another triangle, drop a different perpendicular, and show the same thing for angle C. But it's not necessary. Uh, so law of sines. So let's write it as sine of B. That's how it's in your textbook over B. We don't have to write the sine for the angle. So sine of B over B, why don't I start with A? Sine of A over sine of A over A equals to sine of B over B equals to sine of C over C. So some of you probably thinking that, well, wait a minute, if I have, like with fractions, if I have 1/2 equals to 2 over 4, isn't that the case that 2 over 1 equals to 4 over 2? And the answer is yes. So the same thing for law of sines. We can also extend that to A over sine of A equals to B over sine of B equals to side C over sine of angle C. Well, I hope you like this video. Thank you.